This lesson we're going to talk about symmetry, different types of symmetry. A figure has symmetry if a rigid motion can map the figure onto itself. So if we can move it and have the same picture again, and then consider it symmetry. So remember, our rigid motions are reflections. So if we reflect it, and rotations. And the other one we had was translation, right? A slide. Now translation does not give us symmetry because once you slide it, it's gonna be a different spot. The whole idea is, could I do one of these guys? Like, could I rotate it and have the same picture, or could I reflect and have the same picture? Let's look at reflection symmetry. So reflection symmetry is one, right? If I could cut the graph, if I could cut it in half and reflect it across, let's say this line M, I contend that this would be the same picture, right? If you flip it across this line. The same thing works horizontally. Again, pretend that was halfway. This line here, that would cut that you can flip it across this line here and you get the same picture. So we'll say line M, and N are lines of symmetry. Like that. So we can also do rotation symmetry. So rotation symmetry is when we could rotate the graph and get the same picture. So if I look at this picture here and I rotate it, right, upside down, that'd be 180 degrees. Now I know it's a little off, but if I move it, it's the exact same picture. That's rotation symmetry, right? I can't do anything else because this doesn't work. That's not the same. That's already a full 360. So that's rotation symmetry. So that's sort of the point in the middle. And you can spin it either direction. The rotation of 180 degrees along P maps onto itself. So that's the idea, right? It could either be reflection symmetry, you kind of cut it in half and reflect across that, it'll be the same, or rotation symmetry, where you can rotate across a point and get the same picture. So which transformation can map the figure onto itself? So this one here, first let's check if I could rotate it. It's like that, copy, paste, same picture. If I rotate it, so that's not the same picture, right? It doesn't fit upside down though. There we go. That's the same picture. So it does have rotation symmetry. So it does rotate. So rotation of 180 degrees. So it does have a degree sign. So it does have rotation symmetry. Now can we cut it in half? I believe you cut it in half right there. You get the same picture. And if we cut it in half this way, right, you get the same picture top and bottom, right? So that means if we flip it across that, it would work. So we have two types of rotations. We have a horizontal reflection over the center, and then we have a vertical reflection. Like that. Okay, how about this one here? Oh, this is smiley face, right? So we could try the thing where, let's see if could I spin this upside down? Not the same, not the same. 180, not the same. No matter what I do, you're not going to get the same picture. So it does not have rotation symmetry. But we can cut it in half right down the middle. Right? So it does have reflection symmetry over vertical line through center. Like that. Okay. How many lines of symmetry does these things have? So we look at this one here. There's a line of symmetry through, let's start with an easy one, right? Halfway down here. That's a line of symmetry. There's one. Well, if I do another edge right here, it's another one. That's 2. I could do one right here. That's 3, right? All those cut that picture perfectly in half. I have a little bit more though. What if I did this? Right? Aren't those two the same? So that's 4. I could do the same thing with this one. That's 5, and I could do it one more with this one. Right? That's 6. Right? All those, if you look at the lines, they're the exact same picture on either side of them. That's how you know it has right symmetry. If we cut it in half, It's the exact same picture on either side. So a hexagon has 6. A regular hexagon, I should say, a regular hexagon has 6 lines of symmetry. Like that. Okay, if you look at these real quick, how many lines do these have? Well, this one, again, for looking for lines of symmetry, it has 2. I can cut it in half right here. I can cut it in half right there. So that's 2 lines. We're talking about lines of symmetry. We're not talking about rotations, right? Lines of symmetry. How about this one here? This one only has 1 right down the middle. Right? If I try to cut it this way, it's not going to be the same. So this only has 1 line of symmetry. So it's a vertical line. Like that. Okay, how about rotations? How many different ways can I rotate it and have it map to itself? So far, we've been doing a lot of point symmetry. Point symmetry is when a type of symmetry in which 180-degree map figures onto itself. So like here, right? If I put that 180 degrees, I get the same picture, just like we did up here with this guy and with our rectangles up there. Now let's do something that don't have that. So like, how many rotations can I map it to itself here? So let's look at this. Right, copy and paste. Let's label our vertices so we know what we're talking about, right? So this is C, this is B, this is A. All right, let me get this and let's spin it around. And you can see that one's the same. Right, where now C is on to, like A got moved to the B side. That's a rotation, right? It's not 180, it's less than that. And then that's also the same, where A gets mapped onto the C side. And then after that, if we go all the way back, we get back to our normal one, like that. So there was 3 different, like you have 3 pointy lines, right? So you have one that moves there and one that moves there. So if we did 360 divided by 3, you would get 120. That's how much each rotation is. So think about this as 120. So we did on one rotation to 120, like this 120. Then we did another rotation to 240. So those are my rotations. So of 120 rotation and a 240 rotation. Right, 120 got the A moved to the B. We moved 120 degrees from here to here. Then when we moved from here to here is another 120, so it's a total of 240. So how about this parallelogram, right? So let's go A, B, C, D. So same concept. If I could rotate this, what would it be? So like that, right? If I spin this around, not the same, not the same, not the same. And now it is the same, and it's upside down. When that happens, it's a 180-degree one. And if I spin it again, which I don't think I can do, I don't see the edge, but it's 180 degrees. So that's what this one is. 180-degree rotation. How about if I look at this one? Now, you don't have to like rotate yourself. You look at this one, right? Every turn, it's going to be the same. So this is going to be basically cut it in half every 90 degrees. So to go from A to B, C to D. Right? If I take this point and then I rotate it to here, it'll be on this one. Then I rotate it again, another 90 degrees. So this will be 90. And then 90 plus 90 is 180. Plus another 90 is 270. So I have rotation of 90, 180, 270. Right? Because this is a 90. Then we do it again, we get another 90, which makes it 180. We do it again, we get another 90, which makes it 270. And the circle here, it's an oval, right? This I can only flip it upside down. Because if you do it any other turn, it's not going to be the same. So this would be a 180-degree one. Determine similarities. What type of similarities does each of these figures have? So looking at this one, this has rotation symmetry for sure. Right? It's going to be all these. If I turn it once, I get this one. If I turn it again, again, and again. So there's 5 types of rotation here. If you want to figure out which one they actually are, well, we get 360 and divided by the number of points we have, right? We have 1, 2, 3, 4, 5. So 360 divided by 5 gets us 72. So every 72 degrees, we have a rotation. So 72 degrees, and then another 72 degrees will get us 144. Another 72 gets 216. Another 72 gets about 288. Right, once you get to like 360, then that doesn't count anymore. Right, so every 5 points of rotation from here to here, here to here, here to here, here to here. So you have a rotation symmetry. And then let's see if we have a reflection symmetry. Right, I would say that cuts it in half. So the same thing would happen when I do this, and when I do this, and when we do this, and when we do this. Right, so we have 5 points there, one for each star point. So there's 5 points of rotation symmetry. Reflection symmetry, sorry. Like that. This last one here. Now, keep in mind these dots here. Those dots kind of mess it up. So what it messes up is my reflection symmetry. I can't cut it in half anymore because this dot is not the same thing as this dot. Otherwise, that'd be fine. I could cut it in half, even though my cut's bad, right? But since that dot and that dot are not, these are not exactly the same, that does not count. Same thing when I do this, right? These sides are not the same because of these dots here messing me up. So it doesn't have that. How about rotation symmetry? If I rotate it upside down, will it work? And if I do this, not the same. Ah, look at that. It's the exact same thing. So it does have rotation symmetry of 180 degrees, right? Flip it upside down. So that's rotation reflection symmetry. That's the video.